thecasesolutions.com. Hey guys, this case is about decommissioning of gas and oil offshore structures, Harvard Case Solution and Analysis. Introduction. Decommissioning term refers to the final stage of an energy platforms. In gas and oil, when production life cycles come to an end and all usable gas and oil is processed, the offices should be destroyed and the encompassing region gets back to its normal condition. Summer 2019. However, there are different choices that involve reefing the lowered segments of the stage structure. Decommissioning, as ordered in a scope of national policies, ought to occur in a naturally safe and socially responsible way. Manion, 1980. The gas and oil infrastructures are aging globally, and the community is quickly approaching to the decommissioning crises. Currently there are approximately 7,500 structures which are built for the industry of hydrocarbon, e.g. oil structure, rigs, and platforms. These structures are located offshores, out of which 85% are going to absolute and need decommissioning within the following decade. Topham, 2017. Most countries require total expulsion of out-of-date structures, which requires significant engineering provocation and is assessed through cost of gas and oil industry in abundance of $40 billion. Topham, 2017. A huge extent of this expense will be given to the overall population through tax concessions stood to industry, approximately estimated in the UK, 30 to 70%. Probably these costs are going to have an extensive socio-economic impact which owes to affect the regional and local economies. Watson, 2019. Complete evacuation of structures policies depends on the assumption or understanding that leave the seabed, as you establish it addresses the sound environmentally decommissioning choice. Ioannou, 2018. However, we have recently realized that oil and gas structures are equipped for creating abundant and different marine networks during the period of production, with certain structures supporting the networks of territorial importance. Ioannou, 2018. For example, northern Gulf of Mexico oil structures support an industrially and casually significant Lutjanus campechanus, red snapper, and stages off Southern California that support generous adolescent populaces of a decreasing rockfish species. In different cases, oil constructions might give significant natural surroundings to guarantee the network of population, as it has been conjectured for deep-water corals in the region of northern Atlantic. In some nations, the removal of these structures did not address the best ecological practices and left the old structures set up as counterfeit reefs, RTR, rigs to reef, Vellenturf, 2017. So, to analyze the decommissioning of gas and oil structures in the UK and Australia, this research is constructed on the basis of literature review. This literature review will investigate the impact of sustainability in the industry of oil and gas. It will be helpful in identifying and understanding the key parameters that affect the decommissioning of offshore structures, and this study will also help in decision-making after helping us identify that whether this is an opportunity or threat. And this will also reflect on the possibilities which tend to be impactful on these platforms, ecological and environmental considerations. In spite of the fact that many structures have been already decommissioned around the world, few research studies have observed the ecological and environmental networks conditions beyond the evacuation of the structures. Manion, 2005. Here, we audit the ecological impacts of decommissioning choices, drawing on information on the biology of the marine networks on structure, also on science and nature in different frameworks. Increasing the understanding of the offshore oil and gas industry and its effect on the environment is essential to achieving a sustainable future for the industry. Margules, 2000. The global nature of the sector means that it affects every region, habitat, and species in the world. The benefits of an ecosystem-based approach to decommissioning will benefit not only the industry but also society. PPC, 1996. There is a number of options available, and the analysis should take into account the net environmental, social, and economic impacts of each. Manion, 2005. For decommissioning, the rigs to reefs approach is the most promising, as it converts decommissioned structures into habitats for marine life. Studies have shown that artificial reefs are highly productive fish habitats. In a recent study, Margules and colleagues compared the ecological effects of 3 different decommissioning scenarios for 24 California oil and gas drilling platforms, PORs, 2011. They gathered data using a combination of bottom trawl surveys and observational data from divers and crewed submersibles. The study focused on the impact of decommissioning options on marine environments, Hodgkinson, 2018. The most prominent options are to leave oil and gas platforms in place, toppling, relocating, and converting them into artificial reefs. The AIMS research found that these structures are a source of novel habitat for many marine species. The study also highlights the need for ecosystem-based decommissioning and optimization. While decommissioning offshore oil and gas platforms has a negative impact on marine ecosystems, the UK government enforces a strict, clean seabed policy. Under the decision of OSPAR 98/3, oil and gas platforms are to be completely removed from the seabed once they are decommissioned. The removal of platforms from the seabed would result in the loss of the enhanced ecosystem. There are 2 key methods for decommissioning offshore oil and gas platforms. First, the rigs to reefs approach turns these structures into habitats for fish. For example, removing the platforms in the Pacific Northwest has a high rate of extinction of sea turtles, and a large percentage of these creatures live in shallow waters. Secondly, the Blue Latitudes approach reduces the overall cost of offshore oil and gas rig removal. Hodgkinson J.H., 2018. In addition to the environmental concerns, offshore oil and gas decommissioning can impact the marine ecosystems as well as indigenous populations. Hodgkinson J.H., 2018. Moreover, it has a negative impact on a number of species. This includes fish, birds, and other creatures living in the area. In a nutshell, there isn't any guarantee regarding the decommissioning of the platform having a positive impact on the ecosystem. Georg, 2018. The scientific community should understand the ecological impacts of MMS before proceeding with decommissioning. In addition to this, there are also other considerations related to the impact of the MMS on the ecosystems. Wang, 2019. MMS, like wind and solar turbines, can disrupt the function of ecosystems. In the North Sea, for example, the installation of offshore wind farms has been known to alter the ecology of the surrounding environment. There are a number of other factors that are responsible for the ecosystem impacts of offshore oil and gas operations. For example, an agrochemical project can cause damage to a marine area's ecology. In addition to deforestation and pollution, the oil and gas industry can have a profound impact on ecosystems. In fact, the environment impacts of the industries and their activities are often more severe than the impacts caused by human to the environment. This is just a sample partial case solution. Please place the order on the website to order your own originally done case solution. Thanks for watching this video. Please like and subscribe our YouTube channel. If you want any case study, visit our website thecasesolutions.com.